Get RF analysis power in the palm of your hands with our new full-featured real-time USB spectrum analyzer.
Hello, this is Frederick from Tektronix. I'm coming back here tonight with an update video, and we're going to look at the RSA5000 and 6000 in general, which is the bigger instruments, versus the USB 3.0 real-time spectrum analyzers. And some of you already have noticed that there's been 3 updates. There's one RSA306B now. I expect it to be delivered tomorrow. And there will be 2 new series based on the same USB 3. It's a 500 and a 600 series. Hopefully I will come back with information and some tests about those products shortly. But this video is really related to the bigger instrument versus the USB 3 and what's the difference. So I collected some questions when I've been traveling, and I tried to go through them one by one. So let's start by showing you this. So here is one thing that you can see, and I can go in here. We have the frequency. I can set these guys to max span. And the first thing you can see is a difference in the frequency coverage or frequency range. One goes from 1 Hertz more or less up to 26.5 gig, and the USB from 9 kilohertz to 6.2 gig. So that's the other thing. If I go for preset here, you can also see that the maximum modulation bandwidth for the RSA or the USB spectrum analysis is 40 megahertz. And the instruments here I'm using are an RSA5000 It's actually having 165 megahertz modulation band or demodulation band. Next, people ask me, I'm just going to put it at 3 gig because I have some antennas on here. So just want to show you how good it is. So 3 gig. The other thing that people ask me how good it is, in spurious-free dynamic range and all. And one test I probably do is just to do an averaging like this, and then marker, just add the marker. I do the same thing here. I just enable RSA3 and I just add marker. So without doing anything here, we have 300k and 1 meg, so I will probably have to change this to a comparison to 4040, and now they should be comparable. So this one is like 82 here, and this is 70 here. So it's a 10 dB difference more or less. Let's tweak this down to see, what is the lowest signal we can measure. So if we go down here to 10k, can go down lower, but 10k seems to be something that some people use, 10k. And here we can read minus 82, and here is minus 95. And now if we want to measure the lowest signal we can do, we can tweak down the ref level here to minus 40 or something, but it doesn't really matter in the end, it's just moving it up. So here we can measure now minus 105 or 107, and we will do the same thing with this one. We put this at minus 50. Now it's probably the same, minus 104 and 105, but here's the difference. In the setup, there's the amplitude settings. I can have an internal attenuator, and I recommend people to go for 0 here. And now we're down to minus 115, which is 10 dB still. And then I boost in the preamp. And now we're down to 125 dB, which is pretty good. So that's the other difference, is that they can go a little bit lower. I have a little bit more control. But now let's start with some fun stuff. You can see the difference. The next difference is actually how fast it is in DPX mode. So I will go with this one and do DPX, and you know this for sure. I will just change the center frequency to 2.4 gig, and I will do the same here if it lets me. Yeah, it's a bit slow. 2.4, I'll go with this one, DPX, here you are. And there we are, cancel. 2.44 gig is actually where we want to go. Sorry for this. 2.44 gig. So if you run this is similar like this, you've seen the settings. 2.44 gig, thank you very much. You've seen the settings here. And one of the reasons it looks like this is because of one thing. It's that the RSA306 is in my desk, and the 5000 is actually in the basement, so the reception is not the same. But if you look at it, the lively feeling is probably the same, and we can go in here and we can tweak it a little bit. So we set up the ref level a little bit. You can also see that this doesn't look the same as this one, so I will change this to 40 so you can get a little bit more feeling what I'm doing. Secondly, I need to go in and tweak this, bitmap scale and auto color, and now you start to see this. This is a little bit slow now, it's recording at the same time. So, and then of course you can take this center panel zoom and just move it around a little bit in the middle. And you can do the same thing here, center pan zoom, so we have it in the middle. The other thing you can do here is, I close this down. I'm sure you've seen this before. Close it. This, and I close this one. The other thing you've probably seen, I'm going to just making sure that I have set up the amplitude correctly. So we can have a preamp on, it looks a little bit better. So you can see some Bluetooth activities down in the basement too. So these are basically, the same thing. Some people say this looks much better. Of course, it's much better. If you look at the, here, and look at the parameter readouts, my POI at the moment is really bad. My PC is doing something I really don't know, but it should be like 100 microseconds. And this one, if I go to this one and I do the same thing, and preference and show parameter readouts is better than 8.3 microseconds. So it will, each of the frames we get, contains more information. So the thing that I sometimes do to get the same feeling is go to the bitmap here and so put it like 10 times more, like 10 seconds. And this will be start to resemble, but still this, this one has more, pixels to work on. The last thing you can do here, which is also really unique, is all the trigger functionalities. If you've been here to the trigger menu, it's like the trigger bandwidth is always 40 megahertz and you can just level trigger. If you go to the trigger on this one, you have RF input, you have power, but you also have frequency mask, density and runt. And there is also time qualification. So there's a little bit more, trigger capabilities. And the one I really do love, and I actually have access to this here in density readout, this one, if somebody know, and it seems to be always off. So there's a box like this. Some people ask me, what's used for? Why do I want to measure how often a signal is there in time? We used it for the bigger instrument there to actually trigger. So I go in here and I put trigger on this. I have the box similar to this and I put it here and I trigger. But how do I know I trigger? We go to view and we go to navigate to view, and you can actually see here I put 100 microseconds, it's a little bit longer time. You can see I'm actually triggering this one, and I can move down here and trigger on the things walking around here, for example. And this is going to be very powerful together with the spectrogram, as the spectrogram only captures the thing that is triggered. So as soon as it's triggered, it will capture this. If I move this box a little bit wider, it will capture more of it randomly. But I can actually look at certain, pikes or worst case, for example, by putting this here on this side. Every time I have something that is a little bit wider, I will capture it. So the capture is really, one of the good things about this, that it's easy to capture. I hope you like this short video, and hope to see you again soon. Cheers, bye.
Get RF analysis power in the palm of your hands with our new full-featured real-time USB spectrum analyzer.